All right, last video or first video, I don't know what order you're watching these in, but 1.3 is our last standard, and it's all about equivalence, right? So things that look the same but are different. So things that are equivalent, 8 plus 2 is the same thing as 10. Sometimes I say I have a daughter that's 10. Sometimes I have a daughter that's 8 plus 2. Obviously, I never actually do that, but there's pros and cons of each, right? If 10 is simple, it's clean, but I don't know where it came from. 8 plus 2 might tell me something like there were 8 students and 2 adults in the room. If you just tell me there are 10 people, I don't really know anything about that. There's no detail. So same but different. Everything's got pros and cons. So if I see something like this, it's messy. It's got a lot of stuff in it. There's parentheses, there's symbols. And so I'm really thinking about how do I make this simpler and cleaner, but still have it mean the same thing, right? So we talked about this. This is called the distributive property. And if you remember, parentheses indicate that we are going to multiply things together. So if I had 4 times 2, I said times because obviously when I see parentheses, I know things are getting multiplied. And so it's the same kind of strategy here. If I figure out what to multiply, though, that's the only part. So we take the number 4, the thing on the outside, and we multiply it by the stuff that's the inside. So I see 2 stuffs in there. I see the 2x, that's one object. And then I see an 8, that's the other object. And now I'm just going to multiply the thing on the outside by the stuff on the inside. So first stuff, 4 times 2 is 8. The 2 is attached to the x, so x comes along for the ride. Repeat with the 4 and the other stuff. So I have a positive 4 with a negative 8, and that gets me negative 32. And that's my correct answer, unless you can do something with this stuff too. But I don't think these are combinable, so I'm just going to leave them together. I mean, like apart, like that. That's it. They're just hanging out together, and that's your only answer. Now, if you're looking for another reason why x minus 32 is the correct answer, essentially what you're being asked to do is you have 2x minus 8, and you have 4 copies of it. So if I have 4 copies of the thing, if you notice, I have 2, 4, 6, 8 x's, and I have 8 and 8 and 8 and 8 and 8, and that's 32. You have all of them negative. So again, the exact same answer. I don't want to draw visuals for everything. If I have a little shortcut here, then I can say, oh, I'm just taking these 2 numbers and multiplying them and bringing down the attachments. And I take any other numbers, multiply them together. That's a nice little shortcut instead. So B might look the same to you as A, but it's just slightly different. So remember, the number that you multiply in front has to be a number. So that 6 is not actually in front of the parentheses, right? It's like kind of over here on the side. So I have to figure out what to do with the number in front there. And hopefully we know that the number in front, when we don't see it, is negative 1. So if it helps you to write that negative 1 in there, feel free to do that. So negative 1 times 4 is negative 4. I'm going to multiply that negative 1 times the second thing that I see, which is a positive 2. So negative 1 times negative 2 is negative 2. Bring down the x because it was attached. They don't get to separate. So negative 1 and 4, negative 4. Negative 1 times 2 is negative 2 with the x. And then you're like, wait, what about the 6 out in front? Great idea. We didn't do anything with it. So if you don't do anything with it, you got to kind of bring it along. You can't forget about it. The only thing I did in step 1 was I distributed that negative 1 out in front, but then I brought everybody else down that didn't have any involvement, meaning that 6. And now I think, okay, is there anything here that's combinable? Because just because I did one thing doesn't mean I finished the problem, right? This is a nice first step. You'd get credit for it, but it's not the simplest expression that we're looking for because I can still subtract 6 minus 4. So since 6 minus 4 is 2, why wouldn't I just write 2? 6 and 4 are combinable because they're both numbers. If I covered up that minus 2x and just, kind of narrowed in like that, if I said, what's 6 minus 4, you'd all know the answer to that question. So you might as well just write the answer to what you know. Bring down the minus 2x because I wasn't involving them. 6 minus 4 is this. That minus 2x wasn't a part of this conversation. So again, I have to bring it along for the ride. So just because I'm doing one thing doesn't mean the other things get ignored. They get ignored temporarily, but they still come along for the ride. So unless these are combinable, which they're not, number with a letter, two different things, the visual of that would look like two X's and two bars or whatever because they are different things. Okay, and that's your answer there. So yay for us. All right, no distributive property here, so hopefully you look at this one and you're like, okay, I'm seeing things that are combinable. The things that are combinable are the X's, and then the things that are the plain old numbers are combinable. So pretend like the other stuff, the other color, isn't in the way. So if I'm focusing my attention on X's right now, I am not going to be thinking about the purples. I'm not thinking about that at all. So it just says literally 5 X's minus 2 X's. So I have 5, I'm taking 2 away. So that's going to be 3 X's. That's where I'm getting that 3X from. And now I'm going to essentially pretend the X's are gone because they sort of are. The 5X and the minus 2X merge to make 3 X's. So they're not there anymore. And now literally all I have is the statement 10 minus 4. I'm not going to write the plus sign in front of the 10 because it's, it's implied there. And 10 minus 4 is 6. So that's all I would do to write that answer there. Oops, I'm sorry. Plus 6. Because 10 minus 4 is 6. Okay? All right, one last one. You look at it and you're like, all right, I see that parenthesis looking thing. I know what to do there. 3 times 2 is 6 with the X. Positive 3 times negative 5 is negative 15. I didn't do anything with the 4X's. We're not multiplying that 3 by this stuff here because it's not in the parenthesis. If it were, then we would, but it's not. And now we're looking for things that we can do if anything is combinable, which they are. 6X and 4X, that together makes 10 X's. And then the minus 15 and the plus 25. You're like, I don't know what that is. Not a problem. That's where a calculator can help you out. But we're typing in as is. So negative 15 plus the 25 is a positive 10. So I'll write that plus 10. You can use your calculators. You can use your brain. 25 minus 15, if you think about it in the different order, is 10. So however you're thinking about it. These are not combinable. Letters, numbers, different things. And so that's your correct answer there. All right. Maybe you skip through this whole part and you're like, okay, I know how to do these things, but I don't know how to do these. And that's just when you get tunnel vision, all right? So instead of being overwhelmed by all the blanks, focus on one piece of the attention. And I always focus on the X's first. That's my strategy. Doesn't mean it's going to work for you, so we can come up with some other ones. But I'm just going to focus on the X's. There's 5 X's on the left and 7 X's on the right. So if there's 5 X's on the left and 7, they need to be the same. That's what the equal sign means here. Same. So if I have only 5 X's, I think it makes sense that we need 2 more. So I can't just write that because I didn't add 2 X's. I only added a 2. So we're adding the 2 X's here. All right, now I've balanced my X's, meaning now I've got 7 X's on the left side and 7 X's on the right side. So the other stuff has to be the same too. So what I could write is 10 minus 9 because that's what I see here. So if I see 10 minus 9 on the left, I'd have to write 10 minus 9 on the right. But one blank, this one blank spot, can only have room for one thing in it. So you can't write 10 minus 9 because that's 2. So if there's 10 minus 9, which we know is 1, we've got a 1 on this side, so we'll need a 1 on that side. Now we've got 7 X's on the left, 7 X's on the right, 10 minus 9, which is 1 on the left, and 1 on the right, and now everything's the same. And to prove it to you, if you really wanted to, you can think about this that you've written here as something that we did like up here. That looks almost the same to me, except it's not the same numbers, right? So if you got the expression 5x plus 2x plus 10 minus 9, and I said, make that simpler, make it have less stuff in it, you'd say, okay, well, these are combinable, 7x, 10 minus 9 is 1. So it should look like 7x plus 1 on the left, and it should look like 7x plus 1 on the right. So that's another way to just kind of double check these problems. Okay, same thing. Now we've got, again, you notice me maybe here saying like, oh, it's the same thing, it's the same thing. It is all the same thing. It's just in different varieties of it, right? This is a substitution of filling in the blanks so that the left and the right are the same, but instead of combining things, instead of like putting things that are together, we have that parenthesis, which we know is going to include more like multiplication. And again, I'm focusing on the x's. So if I see 7x's on the left side and 21x's or negative 21x's on the right, I need to figure out a way to make that 7 turn into a 21. But remember, I can only put one number in this like place, and that number isn't going to get added to the 7 like it did here. It's going to get multiplied. Can you guys hear the sirens? Oh my God, that's my dog howling. He only does that when sirens go by. Not like, oh, look at him go. It's weird. Dogs, they're weird. Okay, so remember, the number in front is going to the number, maybe he's sad. He wants to go on the call with them. We're going to put the number here that multiplies with this. So I can think of 7 and 3 turning into 21. But I want to be careful here. If I put a 3 there, 7 times 3 is 21, and I have a negative 21 there. So I think that's an easy fix. I think I could just put a minus sign in front of that. And that's my answer. Now, if I fix the 21 issue by putting a negative 3 there, now I need to worry about this box. And the easiest thing to do is just to distribute that negative 3. Once you've decided what that number is in the front, let's multiply it through. So negative 3 times 7 is the negative 21x. Yay, what we were looking for. Negative 3 times a negative 1. 2 negatives multiply to be a positive. And negative 3 times 1 is positive 3. So now if it says negative 21x plus 3 on the left, it needs to say negative 21x plus 3 on the right. So I think it makes sense that that bubble has to have a 3 in it. All right, so ta-da! That's how you do the matching problems. Focusing your attention on the x's, that's a good strategy. You don't always have to do that, but that's one way to do it. And then maybe some of the other blanks will fall into place. But again, the goal is to put things to be the same. All right, one last problem kind of like this. Which expression's not equivalent? So which thing is not the same as the others? Which one does not belong? So already I'm seeing increase, subtract, decrease, decrease. I think my gut instinct tells me it's going to be D, because this is decreasing, decreasing, subtracting, and this is going up. But let's just double check, because sometimes instincts can be wrong, but it's good to have them, right? So this says decrease 6x plus 3 by 1. So make that 1 smaller. All right, well, it's not asking me to decrease x's by anything. So it's just asking me to take 1 away from that expression. If I visualize this, 1, 2, 3, 4, 5, 6, and there would be like 3 sticks. And I need to make this disappear by 1. Well, the thing that I would take away is that 1 stick there. So 6x plus 2. So notice when I say decrease by 1, I'm only decreasing the 3 by 1 because I'm not impacting the x's. This says decrease 7x plus 2 by x. So that says make this thing lose an x. Decrease the x's by an x means I've got 6 x's, and then I've got that 2 that's hanging out in the back. All right, so now I know these two are the same. Decreasing this by 1 affects the number. Decreasing this by x just means we take 1x away. I'm going to look at this one next because this one looks simpler than this. This already is giving me anxiety. So, and that's okay. When you read these and you're like, oh, I'm panicked, there's a lot going on there. It's okay to skip around. Increase 6x plus 3 by 1. So increase this by 1. So again, the 1 is only going to impact the number. So if I increase 6x plus 3 by 1, I'm going to get 6x plus 4. Already, that's feeling different, which is good. So let's just make sure that nothing weird happened in the last one, and then I think my answer is going to be D. That's my prediction. Subtract, that means take away. Take away an x from this, that's 6x. Take away 1 from this, done. So notice you see my prediction of just looking at the words was correct. Then I did a little bit of algebraic work. I realized that this didn't match the others. So again, I used a little bit of intuition to figure it out. All right, sorry again for the really long video, but I hope it helps.